Okay guys, Math 3, we're going to continue with our simplifying radicals. This time we're going to take care of variables with a radical and fractions with radicals and adding and multiplying radicals. I've tried to split up the video, so the other video you can check out variables with no radicals. Alright, so we're looking at this. We recognize, the first thing we need to recognize is that the square root of x squared is x. In other words, x squared is a perfect square. So before, when we were looking for perfect squares, that was what we were looking for. Okay, my example here is we're going to split this up into small groups of x squared. In this case it was a squared, and a, because of 2 plus 2 plus, remember there's a 1 up there, 2 plus 2 plus 1 gives us the 5. And then I recognize that a squared, square root of a squared is a. And then the next one, the square root of this a squared is also an a, so when you put those together, it becomes that a squared. We're going to try it down here. Alright, I recognize that I have x to the 6th. I can split that up into 3 different sets of pairs, 3 pairs of x squared. So here's an x squared, here's an x squared, and here's an x squared. Well, each and every one of those is perfect. So I can do those perfect squares, and I get x, which of course we know that really is just x to the 3rd. So there's my answer. The square root of x to the 6th is x to the 3rd. We'll look for a pattern in a minute, and that has to do with this shortcut. We're going to try a to the 9th. Again, I divide it up into pairs, and we recognize immediately that I can do a squared, a squared, a squared, a squared, and then there's one a left over, right? That 9's an odd number, so when I try to divide it up into pairs, I always have somebody left out. Well, each of these are perfect, so I know that. But this last guy here, he wasn't a pair, so he's not perfect, so I have to just bring him down. And when I simplify that, of course, a is a to the 4th, and I have an a left over. Now we'll talk about first shortcut in a minute. Try it a little bit longer, see if we can do this. Alright, looking at this middle one here, h to the 7th here, I'm just going to move it off to the side. I start writing them out in pairs, but you know what? I realize almost immediately, man, I don't want to do this every single time, and I don't want to have to write all of these out in pairs. Now I could, and it will work, but I need to recognize the shortcut, and the shortcut is up here. Okay? I recognize that if I'm looking for pairs of numbers, pairs of course means 2. If I'm looking for pairs, I can just divide that exponent by 2. 6 divided by 2 is 3. And guess what? I had 3 perfect pairs. So my answer was x to the 3rd. 9, if I tried to find pairs, that ended up not being perfect, did it? Because 9 divided by 2 doesn't work. But how many pairs did I have? Well, 9 divided by 2 is 4. 1, 2, 3, 4. But also there's one remainder. So 9 divided by 2 is 4 with a remainder. So that ends up being 4 with one remainder. So I'm going to try to do this h that way. Okay? And I hope you see right here, I've got h to the 7th. Well, h to the 7th, 7 divided by 2 is 3 with one remainder. So I have 3 pairs that are perfect that'll come to the outside, but that one that remains has to remain on the inside. Let's do it with the G11. 11 divided by 2 is 5 with one remainder. So I'll have 5 that come to the outside and 1 that has to stay on the inside. Now with the k to the 8th, 8 divided by 2, that does work out perfectly. I have 4 perfect pairs. So I'll bring all 4 pairs out, and that should be the answer. Try it again with 8x to the 5th. You have to deal with the number, just like we dealt with the number before. And this time I'm going to write all the pairs out, since it's a smaller number. So once I have everything written out, I'm going to kind of look for which ones are perfect and which ones aren't. 4 was perfect, x squared was perfect, and another x squared was perfect. So I bring those down. And then I had 2 left over that were not perfect. And I bring those on the inside.